Today we're going to take a look at how we find the measure of angles formed by segments. Okay, so you're going to learn more circle vocabulary today, and you're going to learn theorems about the angles inside and outside of the circles. So a chord is just a segment from one side of the circle to the other side. So in this case, EB would be considered a chord, and so would CD if we name it just as a segment. So chords would be EB and CD. Okay. A tangent is a line that just touches the circle at exactly one point, or it kisses. I like to say it kisses because it gets a laugh out of middle schoolers. It just kisses that line. Okay. So in this case, line A would be your tangent. So line A is your tangent. This point right here where they intersect is called the point of tangency. And a secant is a line that intersects the circle in two places. So every circle is either intersected in two places, unless it's a ray that's going through there. But here, my secant intersects at both D and C, and line DC is the secant. So chords are segments, and secants and tangents are lines. Okay. If we have a tangent and a chord intersect a point on a circle, then what it's really doing is intercepting an arc, much like what we've already done. So here, measure of angle 1, or angle 1 intercepts arc AB, so just like the intercepted arcs from our last lesson, it's going to be half the measure of that arc. Okay, measure of angle 2 intercepts arc BCA, so it's going to be half BCA. So in this example, we have the measure of angle 1. We're looking for it intercepts this arc. We know that the other arc is 248 degrees, so we know the green arc there is going to be 180, 360 minus that 248, so that this arc is 112 degrees. So the measure of angle 1 is equal to half of that arc, which is 112. So if I divide that by 2, the measure of angle 1 is 56 degrees. Okay. Now, if I have two chords intersecting in a circle, then the measure is going to be 1/2 the sum of those intercepted arcs. So if I look at angle 1, which is this angle right here, okay, it's going to be half of the sum of this, and if I was to continue these in this. So with those vertical angles, they're the same. It's going to be half the sum of the intercepted arcs. So in this example, we have these vertical angles here. They intercept this arc. So the measure of angle X, or X degrees actually, because it's really not angle X, X degrees is going to be equal to 1/2 110 plus 80. So X is going to be half of 190. And that will be 95 degrees. So X is going to be 95 degrees. In the second example, here's my vertical angles, here's my intercepted arcs. So I know that this angle right here is half the sum of these arcs. So 55 is equal to half the sum of the arcs. Now the easiest way to solve this would be to multiply both sides by 2. So if I multiply both sides by 2, I'm going to get 110 equal to x plus 75. And then if I subtract 75 from both sides, it's equal to 35. So x is equal to 35. Right, we have now we've got angles outside the circle, and this time we're going to be subtracting. It's the same formula. The measure of that angle is half those intercepted arcs, but this time we're subtracting. And I actually have a little thing to go by. I've got this far arc right here, and I've got the near arc right here. Okay, the furthest from the angle and the closest. So near arc, far arc, far arc. Okay, so I remember this by saying that the measure of the angle is far arc. So farc minus narc divided by 2 is another way of looking at that. Okay, so let's look at some examples. So here is my far arc and my near arc. So x is going to be equal to 1/2 the far arc minus the near arc divided by 2, or 1/2 of that. So x equals 1/2 of 60, which is 30 degrees. Okay. Same thing. Far arc and near arc. Okay. So 1/2. So my angle, the measure of my angle, equals farc minus narc divided by 2, or 1/2 farc minus narc. So 30 equals y minus 62 divided by 2. If I multiply both sides by 2, I'm going to get 60 equals y minus 62. If I add 62, I'm going to get 112 equals y. Now here I've got two tangents, and if you notice with these tangents, the angles are congruent. So that means that the arcs here are also congruent. So this arc is x degrees. So there's 360 degrees in the circle, so 360 minus 112 is 248. And since there's two of those arcs that are congruent, we're just going to divide that by 2 and get 124 degrees for x. All right, last example. All right, so now same thing, but now we got a lot of algebra going on here. So I got the far arc, I have the near arc. This angle is the same, they're vertical, so that inside angle there is 9x plus 4. So 9x plus 4 equals 1/2. 26x minus 5 minus, and you want to put that in parentheses because you're subtracting that, 7x minus 2. So if I get rid of my parentheses, 9x plus 4 equals 1/2. So this is 26 minus 7x, which is 19x, negative 5 minus the negative 2, which is the same as plus 2. So negative 5 plus 2 is negative 3. Okay. So now I'm just going to multiply, again, I'm just going to multiply both sides by 2 rather than deal with the fraction. But I have to remember to distribute so that I get 18x plus 8 equals 19x minus 3. Okay. If I subtract 19x from both sides, I get negative x plus 8 equals negative 3. If I subtract 8, I get negative x equals negative 11. So x equals positive 11. So today we looked at some more circle vocabulary and some formulas about angles inside and outside of the circles. So have a math-tastic day.